Hi everyone. This is going to be the pre-lab for lab 10, and we are going to be looking at neural networks today or this week and next week. So before we jump in, I just want to kind of point you guys towards a good resource that I used to learn about neural networks in undergrad, three blue, one brown. He has a lot of kind of like cool math and computer science videos, and he has a whole series on neural nets. Obviously, this isn't required or anything, but if you're feeling kind of a little uncertain or like nervous about like interpreting and kind of learning about neural nets, I think that this series is a lot more expansive than the 5 minute video that you guys will be watching in class or in lab on Monday. Um, but yeah, obviously not required, but I just want to make you guys aware um, of this resource in case you want to learn more about it. Okay. That being said, we are going to be using neural networks to kind of predict what letter is being written based on like pixel luminance data. So kind of after we get set up here with our setup code section and then our defining the problem section, we can run this section 2 and it'll kind of show us like a little bit of the schematics of a couple of the letters. So you can see we're looking at um, character 1 and character 2, so A and B. We can kind of see the schematics of how those look. Whoops. We can also set up our kind of like specifications for our neural net, and then we can go ahead and view the schematics of that neural net. So we can see we have our input layer, um, some weights and activations, and then we have our 25 hidden units here, and then how that kind of feeds into the output layer. And you can see here that kind of in our hidden layer, we have this like nonlinear transformation of the weighted values that get thrown in from the input layer. After we have specified our net, we can start what's known as training the neural network. So splitting your data into training and testing sets is kind of like one of the core tenets of machine learning. We don't want to evaluate the performance of our model on the same data it was trained to, because then it would kind of like overfit, so to speak, to those data. So we can kind of see, right, like based on this new novel set of data that the network wasn't trained on, how well does it perform on that? So starting out with the training, this will take, up to a minute. So I went ahead and ran this ahead of time. You can see it took me 20 seconds for it to run. And we can see that it stops at kind of like a predetermined like decrease in like the error along the gradient. So kind of like, once it stops improving by a certain amount, it just kind of says, that's good enough. And you can go ahead and look at the new network diagram post-training, and we can see now we still have our specifications that we had before, but now we can see the input space is now 35 and the output space is now 26. So instead of kind of having that like blank slate of like 0, 0, we have now our like 35 like bit values. Um, and then like our 26 letters, and there will be like 26 output nodes. And each one of those kind of corresponds to a probability based on everything that kind of happened in these hidden layers, how likely we think it is that the image that we put in corresponds to like any given one of the letters. After that, we are going to kind of continue to do the same thing of training a new neural network, except we're going to train it on kind of this noisy data. So we're going to add some random noise. to the letter bitmaps. And then that's going to kind of be a good test of, and then like we're going to train a neural net to that. And then we can kind of look at based on the level of noise that we allowed each of the numbers to train on, how well do they do across kind of some other like, noise levels. So we can see that's like as the noise is kind of lower, our model trained without the noise kind of outperforms. But that difference kind of starts to level off as we increase the noise, but it's continually kind of like outperforming the model is trained with the noise. Um, yeah, kind of pretty basic forward neural nets. But if you are worried at all about like the complexity of it, because it is kind of a complex topic, go ahead and check out those three blue, one brown videos.